So in lesson 1.3 here, we're going to take a quick look at some multiplication and division and some strategies for that. Probably we've all done multiplication and division, but let's just consider a few things that can help us understand and apply this in an algebra way. So let's think about this. Let's say you have been asked by your boss to get some donuts for the company meeting, something like that, all right? So you get some box of some yummy Krispy Kreme donuts. Here we have a box of donuts. And so how many donuts? Can you count that real fast? Well, we could count it one by one. 1, 2, 3, 4, 5, 6, 7, 8. But that's kind of a little too slow. How else can we do it? Well, we see that there's 3 rows of 4, right? 3 rows of 4, so that's where multiplication comes in handy, right? So we could add them up, but a quicker way to add is multiply. So multiplying is just a quick way to add. Think about that, okay? Well, how many donuts in this box? Again, you could count them all up. Okay, there's a 5 plus 5 plus 5. Or maybe a quicker way would say, oh, well, there's 3 rows of 5. So 3 times 5 is 15. Okay, there's 15 donuts. All right, well, here's another box that has a whole bunch of them here. And, well, how many in this box? Well, what do we got? We got a couple ways to do that. Can you figure out how many donuts real quickly there? What'd you do? Did you do 3 times, what is that, 9, 4, and 5? 9? So we could say 3 times 9. Or, wait a minute, those donuts are the same as that one, right? There's 12 donuts there. So there's 12 donuts. And these are also the 3 by 5. There's 15. So could we have said, well, we have 3 times 4, and then 3 times 5. That's just 12 plus 15. Okay. Yeah, we end up with the same result. Now, you might be saying, well, why would I do that? 3 times 9 is easy. Well, we'll just tuck that back in your mind for a moment. So 2 ways we could do that. Okay. Well, the key is that multiplication is a shortcut for addition. So a quick way to count is just multiplying. So if we have 5 times 3, that means we have 5 3s added together, right? Or could we say that's the same as 3 5s added together? If we kind of read this backwards. Sure, they'll both give us 15. All right, so rather than adding 3 plus 3 plus 3 plus 3, we got multiplying, right? Okay, so let's think about this, okay? Try multiplying these real quickly. And think about pictures like the donuts or some squares or some boxes. Or, how would you multiply those? Think about that. 4 times 15. Well, we might think about that different ways. If we have 4 15s, maybe you know that 2 times 15 is 30. So if 2 15s is 30, then this is going to be, 4 of them is going to be 30 and 30, which would be 60. Maybe that worked. Or you might think 4 times 10 is 40, and 4 times 5 is 20. So together that makes 60. Okay. So a couple ways to think about that there. 9 times 6, well, that's probably one that we just memorized, right? But if I have 9, here's a way to think about that. If we have 9 6s, well, do you know what 10 times 6 is? That's 60. So 9 6s should be 6 less than that, right? If you only have 9 6s, so a good way, by the way, to multiply 9s is to think about what 10 is 10 times that number, and then subtract one of those numbers. So, all right, 54. Okay, some little things to help picture these better, all right? If you have 14 times 25, oh, there's some big numbers. All right, well, it's getting a little bigger. Well, do you know what 4 times 25 is? Well, we know that's 100, right? Thinking like money, like quarters. Well, how many 4s are in here? Well, there's 4, 8, 12. There's 3 4s, right? So 12 25s, that's like 3 times as much. Okay, so that 12 25s is 300. We need 14, so that's 2 more 25s. So if 12 25s is 300 and 2 25s is 50, we got 350. That's one way to think about it. Okay? Or maybe you said this. Maybe we said this. Well, 4 25s is that, and 10 25s, 10 times 25. Anytime you multiply by 10, we just put a number on the end of it, right? That's 250. Maybe we should have just gone there. So if you have 10 25s or 10 quarters, and then you have 10 quarters, and then you have 4 quarters, well, that's 14 quarters. 14 25s, 14 quarters. Add these together, 350. Okay, so you find a way that connects things that you know and put them together. Break it down to simpler problems. So what we use there is a very important property called the distributive property. And the distributive property says this: if you have A times B plus C, that's equal to AB plus AC. What does that mean? That means this. Here's what we just did. We just said we had, we took 14 times 25, and we actually flipped it around. We're going to flip that around, which is something you can do. This is the commutative property. We'll talk more about that. We talked a little bit about that in the last lesson. 25 times 14. Maybe think about that. So that is, we said, well, that's 25 times 10 plus 4, right? And then we did 25 times 10. And we did 25 times 4. And those were easy problems. 25 times 10 was 250. 25 times 4, we said that's 100. Oops, lost my plus sign. And we said, all right, well, we broke it down into 2 easy problems. And since multiplication is just a shortcut for addition, we're just add up the result of those, 350. Okay? So that's all that this distributive property is saying. So let's just see how that can help. Okay, just a tool to start to think about. This is very important in algebra. So 7 times 13. Well, can you break 13 up into 2 easy numbers? Well, 7 times 10 is going to be easy. I think we can do 7 times 10, and I think we can do 7 times 3. Okay, 7 times 10 is 70. 7 times 3 is 21. And now that's a pretty easy adding, 91. So that's a good way to go there. There's other ways. You could break it up differently. How about 47? Well, okay, that maybe is a tricky one. Well, how about we break it up into 40 and 7? So we're going to do 2 times 40 and 2 times 7, because 40 and 7 makes 47. All right, 2 times 40, that's 80. 2 times 7, that's 14. Do you know what 80 and 14 is? That's 94. Now this also works for subtraction. That's kind of what we were saying right here. So you can also do the same for subtraction. You can pick two easy problems, break it into two problems that you could subtract. So 16 times 9 is what we want, okay? So we got, let's break up, we need to write 9 in a different way. See, here we wrote 13 as 10 plus 3. Here we wrote 47 as 40 plus 7. Well, we could do 9 as something plus something, but watch this. What if we did minus? 10 is an easy number to multiply by. 1 is an easy number to multiply by. 10 minus 1 is equal to 9. So 10 times 9 is the same, or I'm sorry, 16 times 9 is the same as 16 times 10 plus 1. Oh, it's 10 minus 1. Okay, let's multiply this up. We're going to do 16 times 10, and we're going to think about 16 times 1. What is 16 times 10? Anytime we multiply by 10, we just put a 0 on the end of the number. What is 16 times 1? 16. And we're subtracting because we did a subtraction there. All right, well, we got to subtract, and we've been practicing subtraction. It takes 160. Maybe let's do it in 2 steps. Subtract 10, we get 150. Subtract 6 from 150, we get 144. So use some of your subtraction methods to do that. Other ways to do it. Well, what about 999? Oh boy, that looks like a tough problem. Well, 999 is really close to a number that is easy to work with, and that's 1,000. 1,000 minus 1 is 999, right? So we have 8 times 1,000. We'll do that problem, and 8 times 1. So we're taking a difficult looking problem and changing it into 2 easy problems. 8 times 1,000 is 8,000. 8 times 1 is 8. And we're subtracting because we did this as a minus. Okay, 8,000 minus 8. Well, when you subtract 8 from 8,000, you're going to have 7,990. We're subtracting 8, so 2 would be 2 plus 8 is 10. So it's going to be 7,992. Okay, so that's kind of nice, and that works often. Doesn't always work, but for a lot of simpler ones that we're going to be doing, they'll do that. Okay, so something to think about. All right. Well, when we have larger numbers, we got to do this standard algorithm. So let's go back to what if we have something like 19 times 1 or 241. Well, sometimes it's just useful to go ahead and stack it and multiply. All right. Here's the steps for multiplying. Well, we're going to multiply the first digit, the ones digit, times each of these. 9 times 1 is 9. Now, 9 times 4, really it's 9 times 40. And 9 times 40 is, 30? 9 times 4 is 36. So we're going to carry the 3 up here, that 36. We can only going to put one digit down here, and then carry this one over here. Then we're going to have 9 times 2, which is 18, and we're going to add 3. 9 times 2 is 18 plus 3 is 21. Now this number here looks like a 1, but it's not a 1, it's a 10. So we're really multiplying by 10, so we've got to put a 0 down here. Then we start multiplying. 1 times 1 is 1. 1 times 4 is 4. Then 1 times 2 is 2. All right, then we have to add, so we're just going to add. 9 plus 0 is 9. 6 plus 1 is 6. 4 plus 1 is 5. 2 plus 2 is 4. So that's the standard algorithm. Think about this. One other way we could have done this, 241 times 19. Let's use the distribution method here. We could have said 19 is really close to 20 minus 1. And then we do 241 times 20. 241 times 1. This is something we could have done. Get my stylus to work here. Okay. 2 times 241, we just doubled them all. 482. And you're going to put a 0 on it because it's 20 minus 241. So could have done that thing. I don't know. This is not worth the time necessarily, but just so you can see that it could happen. That's 48 minus 200. That'd be 46, 45. Yeah, probably not worth it. See, I got it wrong anyways. 69. All right, so standard algorithm is good there. All right, so a couple quick applications, and then we'll wrap up the multiplication part. Okay, so area here. Area is the interior space inside of an object, okay, inside of a region. So like the area of a floor is the space it takes up. Okay, and so when we're thinking of multiplication, it's useful to realize, hey, we're just talking area. So find the area of this. The area of a rectangle. Area of a rectangle is found by length times width. Okay. Or we abbreviate that L times W. So to find the area of these rectangles, here we have a bunch of squares. How many squares is it? Area wants to know how many squares. Well, there's 3 units high, and it is 7 units long. Okay, so we have 3 times 7, which is 21. There's 21 squares there. All right, sometimes we can just think of, if we have a bunch of dots, we're really just finding the area. So if this was a rectangle, and the dots represented the space, then how many dots are there? How many spaces? Well, it's the same idea. This is 2 rows of 6, so the area of that is 2 times 6, which is 12. All right, next page we'll try one more here. More often we got bigger numbers when we're talking about a yard or something like that. Here we want to know how much area this rectangular yard has. Okay. So it's 35 yards. A yard is 3 feet by 21. So what's the area by 12? Sorry. What's the area? 35 times 12. Okay. So we can stack it, but let's try one of our methods. Let's break up this 12 into 10 and 2. 35 times 10 is 350. 35 times 2 is 70. Can you do 350 plus 70? 35 plus 7 is 42, so this is 42 with a 0. All right. And since we have units here, these are square yards. So the squares aren't drawn in, okay, but we abbreviate that square yards, okay. Or we can say 420. Another way we write that is yards to the second power. Either one of those is fine. Okay, so we're gonna stop this video, and then we'll separate the videos so that you have a different one for division.